let's continue. We are going to call this one P, for instance. We call this one Q. Take this as slope, okay? Still, change in Y, or you say change in Y over change in X, or you say change in X. As you can see in this place now, we are taking now a straight line between these points. But this is not perfect. Not perfect, because for a straight line, you have a perfect slope. For this one, perfect slope. For this one now, to get a perfect slope, it must be a tangent to this curve. So let me remove all these ones. So for you to have a perfect line, it must be a tangent. Say the perfect line you want to take, let's say we are taking it from this P point. We get a tangent touching the curve at point P. Okay, let's say this is our point P tangent. Okay? As you can see, because of this tangent, this line that is touching this curve, we cannot take off gradient touching this straight line. So to get the gradient of a slope for curved lines, we use what? We use tangent. Because these guys you are seeing here, they are reserved for straight lines. Okay? And you will agree with me that if you have a curve like this, let me not do this. Okay? Say here, if I have this now, okay, I want to calculate the slope. For me to have it just at point P, not at 2 points again, it means this Q that was here before has reduced, and collide with Q. P and Q. That is, this Q that was here before has reduced. Maybe it was here now, come here. At a point, both P and Q, they collide at the same point. That is the only reason you can have a straight line for it, because this straight line is for P and Q, right? Between these 2 points. I'll manage. Now you have a curve. You did not put P here, you did not put Q here, and you want to still have a straight line so that you can bring in these guys, that is these guys. It's not possible. So the only way is Q need to collide with P. So that you now believe that what? This P that was here, Q that was here, because we need that straight line, they need to be one now. They need to be at the same point so that we can still put that straight line. So we are not taking the gradient at a point. That was why in that second video on differentiation, I told us that what? When S is moving towards 0. Because if you look at this now, for this Q to disappear, that is, it means, okay, I don't know if you are getting what I'm saying. This and this are like this. You have this is Q, this is P, this is S2, this is S1, and this one is coming down. You agree with me that this changes now. The delta is also reducing until there's no more change. The delta is coming towards nothing. That is, the difference between this point and this point, they are nothing. Why would they be nothing? Because we are looking for a way to get a straight line that we can calculate the gradient. I don't know if you are getting what I'm saying. To calculate the gradient. So that's why we said, when this guy, or this guy, because they are the same, when the gap is closing, then we now brought this idea of lim as delta x, the changes between P and Q now, right, is steady towards 0. This, which you can also write like this, lim as this is steady towards 0. This now over this. This one now we now represent it by dy over dx. Okay, so the dy dx you are going to solve from now on in this course is representing the disappearance of Q. colliding with P. The disappearance of Q colliding with P. That's what we are investigating now. That is what this one represents. Because for all this, like this, or y is equals to 2s3 or 5s3, even like this, all this polynomial equation, let's say plus 2 or plus 3, whatever, all these are not straight lines. They are curves. They are curves. They are curves. Could be sine. They are curves. So how do you still get their gradient? That is differentiation. Their gradient now is the y ds. Change the y over change in x. But this particular change in y over change in x is the infinitesimal changes. So the y ds represent infinitesimal changes. Therefore, if you are asked now, what is the difference between the y over the s and this over this and this over this, these two are the same. But for this group and this group, and this group, this is what? Very, very small difference or changes. Why this is what? Reasonable. Reasonable what? Rate of change. So that is rate of change. Okay? So that is the difference. So this one represents this guy when this guy is disappearing, when it's becoming very small. So the reason for that is that we will be able to calculate the gradient of curve. Because before you can calculate the gradient of anything, that gradient must be a straight line. And for the curve we are looking at, they are not straight lines. So we need to draw tangent to touch them. At that point now is what we are calculating the differentiation on. The point at point 2, at point 3, when s is equal to 3. You will see those type of questions. Calculate the derivative of y equals to s squared. That is when s equals to 2. That is at point P. This P now is on the s-axis. P is 2. Calculate the derivative. Derivative is the outcome of your calculation. The final result is called what? Derivative. Maybe I should call this class now derivative versus differentiation. Why differentiation? Is the process. The process of your calculation of solving it out is differentiation. The final result is derivative. Find the derivative of this. Or they say differentiate. Differentiate is an action given to you to do something. Why? Derivative is a noun looking for the final result, the derivative of this. Okay? So therefore, you must understand what you are doing. Because most students, they just go ahead and start solving. They don't know what they're even doing. They can even solve all the integration, differentiation, solve everything in this world. But they don't even know what they are solving. So we are actually looking for the gradient of curves. But because it must be on a straight line, to bring that straight line in, we have to collide this and this together. I believe from now you will not have any confusion on this. So in our next class now, we are going to look at what? The first principle. Okay? Thank you.